How are you, my friends? This is lecture 20 of the pre-calculus course, Trigonometric Identities. In this lecture, we'll see three main ideas: simplifying trig expressions, cofunction identities, and then we will verify some trigonometric identities. Now, just as a review, I put here on one slide all the formulas we have seen so far. See, these are the reciprocal identities. This is the quotient. This is Pythagorean identities, even and odd. We have the first two here, the cosine and the secant functions are even, and the other four are odd functions: sine, cosecant, tan, and cotan. Now let's start with one example. Let's simplify the expression. We have two questions here, part A and part B. I will start with the first one: sine theta divided by cosine theta minus cosine of minus theta divided by sine of minus theta. Anytime you see a negative, it's a good idea that you can use these even and odd identities. Anytime you see that negative here. So we can say cosine of minus theta is the same as cosine of theta. See, it's the same here. And this minus in the question, sine of minus theta is an odd function, so there is a minus sine theta. Now this minus with this minus becomes plus. So now we have sine theta over cosine of theta plus cosine of theta divided by sine of theta. We can combine the fractions. See, like this, x over y plus y over x from algebra. So this becomes x squared plus y squared over xy. So this will be sine squared of theta plus cosine squared of theta divided by the product. See here, you multiply up and down by sine of theta, multiply up and down by cosine of theta. So this is the one here. So 1 over cosine of theta, sine of theta, we can split it into 1 over cosine of theta, which is secant of theta times cosecant of theta is the answer. Now you can try the second one, please, here. Secant squared of x minus 2 secant of x times tan of x plus tan squared of x. That's a nice question to try. Then you can check the answer. Let's see. Now this one will be, this is an expression here. This is similar to something in algebra. We have seen a squared minus 2ab plus b squared. Directly we can factor it as a perfect squared, so a minus b squared. So here instead of a we have secant of x, and the b itself is tan of x. So I can say all this expression becomes secant of x minus tan of x all squared. So if you expand this, you will get this answer. Now let's go now. Secant of x, by the formula, I will put 1 over cosine of x minus tan of x, I will put sine of x divided by cosine of x. And then I combine here the same LCD, you see that one? So 1 minus sine of x over cosine of x all squared. Now this is a squared. 1 minus sine of x all squared, leave it. And this one will be cosine squared. Now cosine squared, 1 minus sine squared from the formula here. Then I can factor in the denominator a minus b, a plus b. Then I will cancel 1 minus sine x, see there's a squared here, and 1 minus x. So the answer here, 1 minus sine of x divided by 1 plus sine of x. The cofunction identities are 6 formulas here. The first one, let me explain the first one. Sine pi over 2 minus x is equal cosine of x. The same for other functions like tan pi over 2 minus x is equal cotan of x. Secant pi over 2 minus x is equal cosecant of x. Let's look at the first one. Now, the first note here, I will say pi over 2 can be replaced by 90 degrees. That's an angle here, 90 degrees. So if you need to change from sine to cosine, or tan to cotan, or secant to cosecant, you can use these cofunction identities. Look at this simple example here. Suppose we have cosine 15. See, this is cosine of x, cosine 15. So x is 15. I need to change it in some question for some reason into sine function. So how can I do that? I say sine 90 minus the x value, which is 15. So 90 minus 15 becomes sine of this 75. So tan 68, see I go here, tan 68 will be cotan 90 minus the 68, cotan 22 degrees. Secant 40, so I go here. Suppose I need to go from secant to cosecant. So secant 40 I put here, secant 40 is there. So I can change it to cosecant 90 minus 40, which is cosecant 50. Let's look at some easy example, I think. Find an angle alpha satisfying tan 6 alpha minus 13 degrees is equal to cotan 65. So we need some alpha that will make this equation true. Well, you can do it any way you like. I will show you one method here you can do. So this is the given here. Tan 6 alpha minus 13 degrees is equal to cotan 65. See, this is the same equation. I will call it equation A. Now let's use the cofunction formula that has tan 90 minus theta is equal to cotan of theta. That's the formula here. Tan 90 minus theta is equal to cotan of theta. In this formula, I will put theta 65 degrees. So I put here 65, I put here 65. I will try to make similar equation to A. So tan 90 minus 65 is equal to cotan 65 from the formula, as I said. So this is tan 25 degrees is equal to cotan 65. Let's call this equation B. Now compare equation A, equation B. On the right side, we have cotan 65, cotan 65. That means the left side, they are equal. So tan 6 alpha minus 13 degrees is equal to tan 25 degrees. So the same function, that means these arguments are the same. 6 alpha minus 13 degrees is equal 25. Take 13 on the other side. So alpha becomes 38 divided by 6. Simplify by 2. We get alpha 19 over 3 degrees. Now example number 3 is very important question. Given cosine of 17 degrees is equal to m, let's find the value of secant 197 degrees plus sine minus 647 degrees in terms of m. So first we look at this angle 197, which is less than 360. So there is no need for coterminal. So 197, let's find the reference. This is in quadrant 3. It will be 197 minus 180. It will be 17 degrees. Now let's move to the other angle, minus 647. This is a negative angle, so let's find the coterminal. So we can add multiple of 360. So we can add 2 times 360 will be 720. So the answer will be 73 degrees. 73 is in quadrant 1. So the reference is the same as the angle, 73 degrees. Now, secant 197, we can start there. This is in quadrant 3, so the secant is minus, so we put minus. Secant is 17 here, the reference. Now, there is a plus here from the question, and then sine, this angle lies in quadrant 1 because the coterminal and the reference, they lie in quadrant 1, so that's plus sine 73 degrees. Secant 17 by the reciprocal, it will be 1 over cosine 17 degrees. Sine 73, we can go to the cofunction identities. We say sine 73 will be cosine 90 minus 73 degrees, which is cosine 17. So sine 73 will be cosine 17, which is m, and this one minus 1 over m. So when you add the fractions, you get m squared minus 1 over m is the value required. Let's look at extra question number 1. Which one of the following statements is true? We have 5 answers there. This is like a multiple choice, A, B, C, D, E. secant squared of theta plus cosecant squared of theta is equal to 1, or square root of 1 plus cotan squared of x is equal to cosecant of x, or secant pi over 10 is equal to cosecant pi over 5, or sine 3 pi over 7 is equal to cosine pi over 14, or secant theta divided by cosecant theta is equal to cotan theta. Now you can take a minute, please, here and try to check which one is true, which means we have 4 false. Let's look at the first 3 in one slide. We see the first one is false because the true one is sine squared plus cosine squared is equal to 1 for any angle, not the secant squared and cosecant squared. So this first one is false. Second one also is false. It looks true, but we have the formula 1 plus cotan squared is equal to cosecant squared. If we take the square root of both sides, we have to have plus or minus. That's the true one. So this one is false. This one, it looks like cofunction identities. Secant pi over 10, I can write it as cosecant pi over 2 minus pi over 10. See, pi over 10 is the x here. See, that's the formula there. Here, if you have the LCD, will be 10. So multiply by 5 up and down. 5 pi minus pi, 4 pi over 10, which is cosecant 2 pi over 5, not cosecant pi over 5. So this one is false. We can see this one is true, the same idea, sine 3 pi over 7. Let's change it to cosine by cofunction. So it will be cosine pi over 2 minus 3 pi over 7. This is the x. Now the LCD is 14 there. Multiply by 7 here up and down, 7 pi. Here multiply by 2, so that will be 6 pi. So it will be cosine pi over 14, which is correct. Now this one is false because secant of theta 1 over cosine of theta and cosecant 1 over sine of theta. When you write it as a fraction, it will be sine theta over cosine theta, which is tan theta, not cotan of theta. Extra question number 2. Find a value for k if secant pi over 5 is equal to cosecant k pi minus 2 pi over 3 plus 5 pi over 6. We have to find a value, one value for k that will make this equation true. Now we start here on the left side by cofunction identity. We know secant of x will be cosecant pi over 2 minus x. We can let x be pi over 5 from the left side here. So it will be cosecant pi over 2 minus pi over 5, which is equal to that one. Here we have the same function cosecant on both sides, then the arguments should be the same. So the LCD here is 10, so 5 pi over 2 minus 2 pi over 10. And here the LCD is 6, so multiply up and down here by 2, 2k pi minus 4 pi. So here when we simplify, we get 3 pi over 10, and this becomes 2k pi plus pi, see minus 4 pi plus 5 pi over 6. Cross multiply, we get 18 pi is equal 20 pi times k plus 10 pi. Let's divide by 2 pi all sides. So it becomes here 9. 20k pi divided by 2 pi becomes 10k. And this one divided by 2 pi is 5. Take 5 on the other side, 4 over 10. So when you simplify, k will be 2 over 5. Now let's look at example number 4, the expression 1 minus tan squared of theta divided by 1 plus tan squared of theta equals 2. There is a multiple choice. Answers, 5 answers there. A is 2 cosine squared of theta plus 1. B, 2 cosine squared of theta minus 1. C, 1 minus 2 cosine squared of theta. D is 2 sine squared of theta minus 1. And E, 2 sine squared of theta plus 1. So the only thing we have to do is simplify all this expression until we see which one is the correct answer. So if I look at the solution of example 4, I can leave the numerator as it is here, 1 minus tan squared of theta. This one I know there's a formula 1 plus tan squared of theta is equal to secant squared. Now, change everything to sine and cosine, and you can do that also from the beginning if you like. So tan theta will be sine of theta over cosine of theta, because we know tan x is sine x over cosine of x. And then the secant of x by the formula 1 over cosine of x, that's the reciprocal. We have here squared. Okay, now we can simplify this complex fraction here. So it becomes cosine squared of theta minus sine squared of theta. Then we cancel the cosine squared of theta. This will be, leave the cosine squared and change sine squared into 1 minus cosine squared. There's a minus outside. So when you simplify, you will get 2 cosine squared of theta minus 1. Let's see, the answer here is B, 2 cosine squared of theta minus 1. That's an easy question. Now, what is a trigonometric identity? An identity is an equation that's true for all values of the variables. So we have, this is an equation from algebra. That's an identity, x squared minus 9 is equal x minus 3, x plus 3. Let's see the trigonometric identities. We have, this is an identity, you see? You have to show that. And this one, sine of x plus cosine of x is equal to 1, is not an identity. It is not always true. So if you have an equation that's sometimes true, sometimes not true, it is not an identity. Identity means when it is always true. Now, let's see some hints or ideas to help you how to show the equation is an identity. I put here 6 ideas you can use. You can split one fraction like this. If you have a plus b over c, you can split it into 2 fractions. You can use that sometimes. Sometimes we can use factoring. We will see many examples now. You can change everything to sine and cosine. That's number 4. Number 3, you can use any formula, trigonometric identity. Then you can add the fractions sometimes or subtract them. You can combine the fractions. And also we can multiply by the conjugate if you have a fraction. I will show you one example on that, number 6. Let's see here, verify. So you have to be careful here. 1 over sine squared of x plus 1 over cosine squared of x. I think that's the one here. See this one here we have to show? That's the example there. Down here we have to show this is an identity. This is example 5a. Now, what do we do here? We have to start with one side, either right side or left side, not both. And then you have to simplify it until you reach the other side. Also here we have to see that 1 plus 2 tan squared of alpha is equal secant to the power 4 of alpha minus tan to the power 4 of alpha. We have to show that equal. Let's see the first one. The first one, I will start with the left side. See, 1 over sine squared of x. I know that these are the formulas used. See, it should be in your memory, in your mind. 1 over sine of x is cosecant of x. So I put here cosecant squared because I have already squared. 1 over cosine squared of x. So that will be secant squared of x. Now there is a formula for cosecant squared of x, 1 plus cotan squared of x. And there is a formula for secant squared of x also, it's written here, 1 plus tan squared of x. That's from your memory. So you add 1 and 1, it becomes 2 plus tan squared of x plus cotan squared of x, which is the right side. So we say done. So you start with one side, simplify it until you reach the other side. I advise you here in this example, special 5b, take a minute to try it. I can give you the idea if you like. Factoring. If you start with the right side, oh, I did not mention. Which one is easier, to start with the simple side or start with the complicated? I advise you to start with the complicated side because easier you can change it to a simple answer. So let's see, factoring. Now this is 5b. Secant to the power 4. So I will start with the right side now. secant to the power 4 of alpha minus tan to the power 4 of alpha. If it looks difficult here, I put here some formulas from algebra you can remember. X squared minus y squared will be x minus y, x plus y. We know that. Now, if we have also in the algebra x to the power 4 minus y to the power 4, it becomes x squared minus y squared times x squared plus y squared. So I can use this second formula here. So this becomes secant squared of alpha minus tan squared of alpha in one bracket. Another bracket we have secant squared of alpha plus tan squared of alpha. Now I have only secants and tans, so I can use this formula, 1 plus tan squared of theta is equal to secant squared. So every secant here, I will change it to tan. Why I do that? Because on the other side here, on the left side, I can see that I need the answer only in tans. So secant squared will be 1 plus tan squared, and also here secant squared will be 1 plus tan squared. There is a minus, see from the factoring, and here there is a plus. Now when you add these, see there is a 1 here, tan squared of alpha minus tan squared of alpha, that's 0. See the whole bracket here, the first bracket is only 1. That's nice. Now the second one, we can add tan squared of alpha, so it will be 1 plus 2 tan squared of alpha. We say done, because this is the left side. Now this is not easy. Let's verify this. Sine of theta divided by 1 plus cosine of theta is equal to 1 minus cosine of theta divided by sine of theta. You cannot cross multiply here to show it. You have to start with one side, either right or left, and show it is equal to the other side. You can pause the video for a minute to try. The main idea here, these two sides are the same difficulty. So let's use the conjugate. So I start, this is the question here. You can start with the right side also. I will start with the left side. See, here we have sine theta divided by 1 plus cosine of theta. I will multiply up and down by the conjugate. I will show you why we do that. No, sine of theta times 1 minus cosine of theta, leave it. And here we have a formula, right? 1 plus cosine of theta, 1 minus cosine of theta. This is like difference between two squares. See, from algebra, if you have x minus y, x plus y, it will be x squared minus y squared. So when you multiply these two, it will be 1 minus cosine squared of theta. That's a formula also. It will be sine squared of theta. Now we cancel one sine of theta all together, not only sine of theta you cancel. You get 1 minus cosine of theta divided by sine of theta, which is done. So why we multiply by the conjugate? So that we can use the formulas that we have. Because almost all the formulas, they have sine squared, cosine squared, tan squared, secant squared. And here we cannot use any formula with sine and cosine. Now this is a quotient, just a remark, no meaning if you don't write the angle. I have seen some math users, some students, some people, they don't write, they write sine over 1 plus cosine, 1 minus cosine, 1 minus cosine. That's all wrong. This is not correct. You must write an angle. Like you write sine theta, sine x, sine a, sine beta, any angle. That's very important. Okay. Now let's see question number 7. Substitute x equals 5 secant theta in this expression. See, this is x equals 5 secant theta. Replace it in this x and simplify the answer. Theta between 0 and pi over 2, which is acute angle in quadrant 1. You can try it. This is a really nice question. We call it trigonometric substitution. So let's see. So I take the expression, given here, square root of x squared minus 25 divided by x. Just replace, inside here we have 5 secant theta all squared, divided by, here there's a minus 25 for sure, divided by 5 secant of theta. Now this one I can simplify as 25 secant squared theta minus 25. I can take 25 common factor inside the square root, secant squared of theta minus 1. Remember, we know the formula 1 plus tan squared of theta is equal secant squared of theta. So if you take the one on the other side, becomes secant squared of theta minus 1, which is tan squared. So inside this square root, I can put here tan squared of theta, replacing this bracket. And square root of 25 becomes 5 outside. Now I can cancel the 5 and continue on the next slide to simplify the answer. Now, if you take from the last slide, we have this 5 times this. So I can take it here. Square root of tan squared will be absolute value of tan theta. But we have tan theta in quadrant 1, so that's positive here. So tan theta will be sine theta over cosine of theta. And the secant will be 1 over cosine of theta. Leave the first fraction, multiply by the reciprocal here. And then the answer will be sine of theta. So this is the expression. The square root of x squared minus 25 divided by x will be only sine of theta. Now, usually I leave some questions, all the exams questions, to practice. Simplify this expression, tan beta cosine minus beta times cosecant beta divided by tan of minus beta. See the answer. Let's verify. This is a really nice question here. Let's verify the identity. And here we have 1 over tan t plus tan 90 minus t. So simplify all this. You will get either tan t secant t or minus 1 or 1 or cotan of t cosecant of t or sine of t cosine of t. One of these A, B, C, D multiple choice. Now here we have a substitution. We did similar. X is equal to sine theta, where theta between minus pi over 2 to pi over 2. Simplify the expression. 5x divided by square root of 4 minus x squared. Another one, if tan 37 degrees is equal to t, then tan 863 degrees plus tan 307 is equal to one of these answers, multiple choice, A, B, C, D, E. Question number 6 is, I said it's not easy. Maybe you will find it easy. The expression 2 secant theta times cosecant of theta minus 2 tan of theta times cosecant of theta divided by secant of theta minus tan of theta all squared plus 1 equals to, simple answer, either tan theta or cosecant of theta or secant of theta or cotan of theta or sine of theta. The answer is really nice. Check it, please. If tan squared of theta divided by secant of theta minus 1 equals, see, you start with the left side for sure here, because we don't know A, we don't know B, we don't know K. So start with the left side. I'm giving you the idea until you reach A plus B cosine of theta divided by K cosine of theta. So there's a number A here, there's a number B, the coefficient of the cosine, and there's a number K there. Then you add A plus B plus K. And the last one is the easiest maybe. Which one of the following statements is not an identity? So I put here A, B, C, D, and E. So sine of x plus cosine of x all squared will be 2 sine x cosine of x plus 1, etc. Secant squared of x minus 1 is equal to sine squared of x over cosine squared. So which one is not an identity? That means there are 4 identities here and one only is not an identity. Now these are the answers for the 8 questions For complete solution, to check your answer, please, you can see the video on trigonometric identities, lecture number 20, pre-calculus old exams questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. Just to remind you that this is pre-calculus course, lecture number 20. I hope I can see you in another video with another topic. Thank you very much. Bye.